if need be in the future. Okay, so let's talk about systems of equations and generalize from 2D to 3D. So in 2 dimensions, we were talking about how 2 lines could be related in the Cartesian plane. So if we recall, 2 lines can be related in the Cartesian plane. Well, they could intersect at one point. And if they intersected at one point, we said that the system was consistent independent. There's one point that satisfies both equations. If they were the same exact line, then it was consistent dependent, and all points on that line, the solution set would be all points on that line, and we would say it had infinitely many solutions. So we could have one solution. We could have no solution if the 2 lines were parallel, right? So we had an empty set, they had no points in common, and we classified that as inconsistent. So again, we can have one solution, we can have 0 solutions, or we can have infinitely many solutions in 2 space. Well, the same is true in 3 space. If we generalize our system of equations to 3D, we can have inconsistent systems. And remember, inconsistent systems, no solution. So how can that occur when we're dealing with planes? Well, they could be 3 parallel planes. Those
Dr.
3.
P.
Yes.
Sorry to interrupt, but if you're share trying to share your iPad screen, we can't see it.
I see it. Can anybody see it?
Dylan said he can't.
Can
I
anybody
can see it.
You can see it. If you cannot see it, please.
And going back and see if that works.
Yeah, because I can see it. I'm looking at the Teams meeting, and so log out and log in. Let's see if that works. Did that help? Can you see it
Still
now?
nothing. Oh wait, just went black.
Can you see it? We're talking about inconsistent systems.
Okay, yeah, I can see it now.
See it now? Okay, great. So again, when can we have 3 planes in 3 space be inconsistent and have no solution? If they're parallel. Or I could have 2 of them being parallel, and the third one, although it passes through each of the other 2, not all 3 intersect simultaneously. So that would be no solution, inconsistent system. Or I could have 2 planes intersecting at a time. And so even if 2 of the planes are intersecting at a time, not all 3 again intersect simultaneously. So all of these are indication that I have no solution. I have inconsistent systems. Now, when can I have consistent systems? When can I have a solution or infinitely many solutions? Well, in the sense of having consistent systems that are dependent, meaning I have infinitely many solutions, well, I could have the 3 planes intersect where they share a line. They have a line in common. So the solution set would be that line, that equation, all points on that line. Or I could have 3 planes all being the same plane. So in that sense, I again have infinitely many solutions, and the solution set would be the equation of the plane, all points in the plane, on the plane. Now, if I'm looking at a consistent independent system, a consistent independent system means I have only one unique solution, and that unique solution is going to be an order triple. Where can that occur? Well, think of, the walls and the floor of a room. They intersect at exactly one point. So that would be a consistent independent system. So we kind of need to be able to recognize when we can have consistent dependent, consistent independent, and inconsistent systems, and how that would be represented geometrically in 3 space. You need to be able to recognize that. Now, let's talk about what happens when we have a system of 3 equations and 3 unknowns. You should be able to perform row operations to get it in the form of a solution matrix. Now, let's just recall what the solution matrix would look like if a unique solution exists. It would have 1s on the main diagonal of the coefficient matrix, zeros everywhere else, and the last column would represent that X, Y, and Z value. So what the solution matrix is the result of performing row operations on an augmented matrix. So no matter whether this is going to be a non-calculator or a calculator problem on the quest that is happening next Friday, we should be able to always write the augmented matrix. Even if it's a calculator problem, I'm going to ask you for the augmented matrix. If you do not write that, you will lose credit. So let's write the augmented matrix. The first thing you want to do is check to make sure that each of them are written in the same standard form. The X, then the Y, then the Z equaling the constant. As soon as you have it in that order and check for that, then you're going to write the corresponding augmented matrix. So the corresponding augmented matrix for this one would be as follows. So you will write the augmented matrix. Now, you should be able to perform row operations to get it as in the form of a solution matrix if a solution exists. What we call this is the reduced row echelon form of a matrix. That means I'm performing Gaussian elimination, row operations to try to get it in this solution matrix form. Reduced row echelon form. That's what RREF stands for. REF is just row echelon form. It's not completely reduced. That means I didn't really get it to the ones, but I can see this little step echelon form. Okay? Now, how do I get the calculator to give me the reduced row echelon form of a matrix? Let's talk about that. We're going to enter in this augmented matrix, and then we're going to ask the calculator to perform row operations and give me this reduced row echelon form. So let me go ahead and share my screen on my computer, get your calculators out, and let's go ahead and talk about how to do that. Okay, so let's clear everything. Let me clear everything and go to my home screen. Okay, so to enter in a matrix in your calculator, you are going to go to second X inverse. So you see this little matrix? You're going to second X inverse. That is allowing you to work with. From there, we need to edit. So I'm going to go to the right and go to edit. Now, it doesn't matter where you enter a matrix. So I'm going to enter it into matrix 1, which I'm calling A. You will have nothing there because you've never entered in a matrix. So I'm going to hit enter and I'm going to select it. The next thing you have to do is tell the calculator what the dimensions, what the order of the matrix is. The augmented matrix that I have is a 3x4 matrix. So you're going to enter in 3, 4, and it's going to give you a blank matrix. Now, once you've entered in a matrix, you can't delete it, but you can override the elements and you can change the order. So that's why I already have this here. So I'm now going to enter in the elements of that augmented matrix. It was 1, -1. Now for a -1, make sure that you're using the negative sign, not the minus sign. Use the negative sign, or you're not going to be able to work with this matrix. So I'm entering in the elements of this matrix. Go ahead and do it real time as well. I'm entering all the elements of the augmented matrix that we just wrote for this problem. And that's why we read it by row, because that's how we enter them in. Okay, so now I have my entries in my matrix. Okay. So everybody entered in their matrix. So double check it, make sure that you're working with the correct matrix, that somehow it didn't skip something and you enter in the wrong elements, because then we're performing the operations on the wrong matrix. Okay, once you enter in your matrix, second mode is quitting. Go back to your home screen. Now, I want to perform the reduced row echelon form. So go back to second X inverse, which is matrix, but now I want to do math. I don't want to edit the matrix. The matrix is there. I want to perform Gaussian elimination. So I'm going to scroll down and I'm going to ask the calculator to find the reduced row echelon form of the matrix. Not the row echelon form. Let's go all the way down to the reduced row echelon form. Hit enter. Now I have to tell the calculator what matrix I want to perform that on. I entered A, so I'm going to perform it on A. I want to find the reduced row echelon form of matrix A that I entered. Hit enter. There it is. Can everybody get this?
No, mine said error.
Okay, then you did something wrong. Did you enter in negative sign for negatives?
Yes, I did literally everything exactly how you did it. I followed step by step.
Something's wrong, right? So go through the process again. Go second, matrix, edit, make sure that you have the correct entries in your matrix, and then second, quit, and then second, X inverse, do math, scroll down to reduced row echelon form, select that, then tell it what matrix you want to perform row echelon form on and hit enter. Okay, now let's go back to our notes and let's talk about how we would write the, what do we recognize once we get that? So let's go back, let's share our screen. Let me go back to our notes and let me write down the matrix. So the row,
Just
got it?
I got it.
Yay, okay. So then we were able to get the row echelon form of the matrix. The row echelon form, hang on one second, it's right there. Yeah, I told you it was out of control. 1, 0, negative 12, 0, 0, 1, negative 10, 0, 0, 0, 0, 1. Now, if I'm looking at that matrix, and I know that each of the rows represents an equation. Each of the rows represents the equation of using X, Y, and Z, right? X, Y, Z, right-hand side. What are you noticing about that last row? If I were to write that, that would be what? 0x plus 0y plus 0z equals 1. Does 0 equal 1?
No.
No. So I have a contradiction. And what do you know that does that mean? If I have a contradiction at any point if I'm performing row operations and I get a false statement, if I get a contradiction, what do we know about this system?
It's inconsistent.
It is inconsistent. And what can you tell me about the nature of the solutions? There is no solution, right? There's no solution. It's inconsistent. So if you're performing row operations and you ever get to the point where you have a contradiction, there is no solution. Okay? So if this were a calculator problem and you were entered in the matrix and you got this resulting reduced row echelon form, you would need to be able to recognize what that means in terms of the classification and the nature of the solution.
So, for example, if that were the question on a test, the correct answer wouldn't be that chart. It would be no solution.
Well, you would write this reduced row echelon form. So a calculator problem, you would write the augmented. You would show me that you're finding me the row echelon form, and then you would point out that you see a contradiction, and therefore it is classified as inconsistent, and therefore there is no solution. So that would be at least 1, 2, 3, 4, 5 points. 6 points.
Okay.
Quest.
Thank you.
Okay, next problem. Let's go ahead and enter this one in. So again, you check to make sure they're in the correct order. You go to your calculator. You enter in the augmented matrix. Let's do that together. And let me switch it to back to and share the screen. I'm going to enter in the corresponding augmented matrix. Again, you should be able to do this by hand, but you should also be able to do it on the calculator. So now I'm going back to second matrix. I'm going to go to edit. I'm just going to override matrix A because I don't need it anymore. It is a 3x4 still. And now I'm going to enter in the values. And you're doing it too. And hopefully you're entering in the correct values. So I'm just going through and I'm entering in the values of this augmented matrix. Again, make sure you use negative instead of a minus sign. So this is one way you can always check your row operations while you're doing your homework right now. Okay, and then I'm going to double check because if I perform row operations or ask the calculator to do it on the wrong matrix, I'm obviously going to get the wrong answer. Okay, so I have everything entered in correctly. I'm going to second quit, second X inverse, which is matrix, do math. I'm going to ask the calculator to find the reduced row echelon form of this matrix. And did you get this? Yes?
I did.
Yay! Okay, so I have a solution matrix. What is the solution to this system?
1, 3, -2.
Yes, and you would have to write that as an ordered triple. So you do have to write the parentheses 1, 3, -2. So again, on a test, you would do the row operations, you would write your solution. It's a unique solution. So how would we classify the system?
Consistent, independent.
Consistent, independent, and it has one solution. All right, so now let's go ahead and look at the next example. I'm going to go ahead and put the next example into my calculator. So let's go ahead and do that. I'm entering in the next example into my calculator. I'm writing the augmented matrix. And again, if this was a calculator problem, you still would have to write the augmented matrix. You would have to write the reduced row echelon form of the matrix, and then you'd have to classify the system and represent the solution set accordingly. So here I am, if a solution exists. I'm entering in the entries, the elements. You are entering in the elements of the matrix. And then I am double checking my entries to make sure that I entered it in correctly. Again, of course, always check to make sure that they are in standard form because, ooh, I have one wrong. See, this should be a -2. Always make sure that your equations are written in standard form in the same order, or else you will be performing row operations on the wrong matrix. Hint, 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 hint. You know I'm not going to give them to you in the right order. All right, let's go ahead and perform row operations. Let's have the calculator find us the reduced row echelon form of this matrix that I just entered. Can we, oh, what did I do? Oh, yeah. Second quit. Let me clear.
Hello?
Yes?
Hi. My internet was bad.
Okay, we're doing the notes and
Okay.
we're entering in matrices into the calculator and we're discussing how to get solutions and stating solutions given the information in the matrix.
Okay.
We're on example 3. I wrote the
Okay.
augmented matrix. I'm recording this so you'll be able to watch it. Don't worry. So is everyone able to get to this point?
Yes, ma'am.
Okay, so now we really need to talk about how we're going to write the solution to this system. Okay, so now let's go back to what we were given. Oops. Let's stop sharing. And let me go back here and share. And let's talk about how we are going to write the solution set to that matrix equation. Augmented matrix. Okay, so I'm back. Let's write the augmented matrix because we always start with that. Okay, so this is what I would write, and then I'm going to find the reduced row echelon form, whether by hand or using the calculator. Using the calculator, I get this. First row, second row, and third row. And what are you noticing? If you get this, whether you're performing row operations or whether you ask the calculator to do it, what are you noticing here?
Z is 0.
Okay, well, no, Z is not 0, or that would be a 1 in here. What are we noticing in this last row? This last row represents 0x plus 0y plus 0z equals 0. I'm getting an identity, right? So I actually see here that I have infinitely many solutions. If you get an identity, should recognize a row of zeros means I have infinitely many solutions. Can you see this? Infinitely many solutions. Do y'all see that? Okay, so as soon as I get a statement that is always true, no matter my choice of X, Y, or Z, I need to know that that means I have infinitely many solutions. So I have a consistent dependent solution. System. Okay, you need to be able to recognize that. Now, how am I going to write the solution set? To write the solution set, I'm going to look at each of these rows, and I'm going to represent that as an equation. So if I take that first row, that is X minus 12, not Y, Z equals 1. Does everybody see how I got that?
Yeah.
Yes?
Yes.
Okay, and then my second row, although something's not sitting well with this. Did we get the right row echelon form of this matrix? No. Let me go back to my calculator. Something's not right. Hang on a second. Let me go back to my calculator and see what's happening. Do I have the right matrix? Let me just check. Okay, I do. I believe so. Okay, that's all right. So then my second, let me go change colors. This equation would correspond to y minus 10z equals -1. Okay, so now I know z can be anything. So if I'm trying to write my solution would be x, y, and z. Now we said z could be anything. So what I need to do is I need to write x in terms of z, and I need to write y in terms of z. So then my solution is this. Okay. Now let's try another one. Now, when we have a row of zeros, we may or may not see them. We may be given the system that is kind of missing that row of zeros that is really inherently there. So if I'm dealing with a non-square system, a system in which the number of variables does not equal, is not the same as the number of equations, I could look at something that looks like this. So if I write the corresponding augmented matrix for this, I have X, Y, and Z, and I have only 2 rows but 3 variables. So technically, there is a row of zeros down there. Now, if I wanted to try to figure out how to write the solution set, and I wanted to get this in row echelon form, well, if I wanted to perform row operations, it wouldn't be so bad. I literally could just interchange these to begin with, because I kind of like that 1 in the first position in the first row. And let's go ahead and try row operations. If I'm going to try to get a 0 here, that means I'm not changing my first row. If I want to get a 0 here, can somebody tell me a row operation that you would perform to get a 0 there? Anybody? So the first
3 R1 plus R2.
Okay. So in the first instance, I interchanged row 1 and row 2. In the second step, I do like that you said -3 times row 1 plus row 2. So what is my new second row of my augmented matrix after performing that row operation? What do you get? 0, right? -3 times 1 is -3, plus 3 is 0. Perform this row operation and tell me what the remaining elements are in this row. Y'all are making me very nervous.
0, 1, 3, 2.
Thank you very much. Okay, now at this point, I see I have gone and gotten 1s here, and I got a 0 here. I don't have another row to try to get to the solution matrix. However, I know at this point I have infinitely many solutions. So I can rewrite the first equation as x plus 2y plus 1 equals 8. That is this. And then I can take the second row and write that as y plus 3z equals 2. That represents this row. Now, I know in my solution, z can be anything from that last row. But I have to figure out how to represent x and y in terms of z. So I can rewrite y as -3z plus 2. So I know y is -3z plus 2. And then I can take that y, that expression for y, and substitute it in here. So in other words, I can take x plus 2 times that y, and then I can keep going. And then I can combine like terms. I'm missing a z somewhere. Where am I z? Oh, that's a z. And then I have x minus 5z equals what? 4, right? And so x equals 5z plus 4. So my solution set is this. I don't need to write that, right? It's just this. So this would be a consistent dependent system because I have infinitely many solutions. And that's how I would write my solution set. Are there any questions? So we did these all on the calculator, but you should be able to perform row operations to arrive at the same answer. Any questions? No? Okay, so you have 6.1 My Math Lab that is due tomorrow now. You do have a 6.2 My Math Lab. It's not due until Friday. Do make sure that you're going back to all the problems that we either did on the calculator or that we left as exercises in our last class, and we are actually doing the row operations and checking them with the solutions on Canvas. The completed notes are there. So make sure that you can do these. In addition, there's a lot of other extra practice problems as well. Okay? So have a wonderful rest of your day, and I will see you next time.
Thank you.